Let's have a look at the 2012 question on coordinate geometry. So the table below gives the equation of 6 lines and it asks you which line has the greatest slope, okay? So when you're given equations of lines, you're always using y is equal to mx plus c, okay? So y is equal to mx plus c, okay? So in other words, what that means is once the equation is written in this format, there's your slope and there is what's called your y-intercept, or where it cuts the y-axis. Okay, so line 1, let me just zoom in a bit, is already in the form y equals mx plus c, because that m isn't just a number, so is c just a number. So I can read off here that my slope for this particular line is 3 and my y-intercept is -6. In other words, the slope is going, or the line is going up. I know that from the positive slope of 3, and it cuts the y-axis at -6. Okay, line 2, slope is 3, y-intercept is +12. Line 3, my slope is 5, my y-intercept, I don't know why I'm calling it y, it should be c, is equal to 20. Okay, this one, line 4, my slope is 1. Whenever there's not a number in front of x, it's not a 0, it's a 1, otherwise the line wouldn't be there. And my y-intercept is -7. Okay, for line 5, my slope is -2, so this is the first line that's going down. I know that from the negative slope. And my y-intercept is 4. And my last line, 6, my slope is 4, my y-intercept is -16. Okay, and I can get that from the equations of the lines. So let's come down then and answer the question, which line has the greatest slope? Well, you're looking down on them and you're seeing which has the largest number. Okay, could be the largest negative number or the largest positive number, but it is line 3. M is equal to 5, the largest slope. Which lines are parallel? Well, parallel lines have equal slopes. That's the piece of theory that you need. Therefore, line 1 and 2, slope of 3. Okay, so part C, draw a sketch of line 1 on the axis shown. So I've just written down the equation of line 1 there, y is equal to 3x minus 6, and I need to draw it. Okay, remember we established that the slope was 3 and the y-intercept was -6. Okay, now it's easy to draw a line when you have 2 points. How do you draw a line when you have no points? You just have the equation. Well, you do have 1 point, and it's where it cuts the y-axis. Okay, so the y-axis, the x-coordinate is always 0, and the y-coordinate we know is -6. So in fact, we do have a point down here at -6. It cuts through the y-axis at -6. Okay, so that's the only point we have. There's 2 ways of doing this. Okay, you can do it through the slopes, or you can check where it cuts the x-axis. So if it's okay with you, I'm going to do it both ways just so you see it. So slope is equal to the y's over the x's, and is often called the rise over the run. Okay, rise being how much goes up and down, okay, on the y's. The run is what they call over and back. Okay, you'd run over and back, or the x's. Okay, so when you have a slope of 3, it is 3 over 1. So to be able to draw in that slope, you would say, well, I'm going to go up 3 on my rise for every 1 I go over on my run. So to do that, I'm going to go up 3 on my rise and over 1. So up to -3 and over to 1. Okay, to draw in, now you only need to join them 2 together, but just for a bit of practice, we'll draw in another point. We would go up 3 and over 1. And again, up 3 and over 1. Okay, and you get your ruler and you draw that together as best you can. And there is the line. Okay, so that's how you do it with rise over run. Or you could ask yourself, where does the line cut the x-axis? Okay, because once you have a second point, it's very easy then to draw the line. You just join the 2 points, because we have 1 point, we have -6 on the y-axis, so that's the point 0, -6. Okay, so how do you find where a line cuts the x-axis? Well, at the x-axis, your y-coordinate is 0. So you put down that line. Why is your y-coordinate always 0 at the x-axis? Well, if you consider the coordinates at this point here, it's 1, 0. This point, 2, 0, 3, 0, 4, 0, 5, 0. So always along the x-axis, that y-coordinate is 0. Okay, so you take the equation of the line, which is y is equal to 3x minus 6. You sub in this 0 for y, and that will tell you the corresponding x value for when y is 0, which of course is along the x-axis. Okay, so I've got x is equal to 2, so write down the coordinates x comma y, so 2 comma 0. Okay, so 2 comma 0 is that point there, and of course it's on our line because we've already drawn it with this way. So what you do is you'd put in another point there and you join these together. Okay, so that is another way of being able to draw a line. Okay, part D then, it flipped the question. It's giving you a line drawn and it's in which line does this represent? Okay, so the first thing you need is y is equal to mx plus c. Okay, what is my c value, which is the y-intercept? In other words, where does it cut through the y-axis? Okay, well you can see it's here. So its y-intercept is 4. Okay, so I now know that my line is y is equal to mx plus 4. Okay, wouldn't it be lovely if I got my slope? Okay, and my slope is again the y's, the changes in y's over the changes in x's, or rise over run. Okay, so what does that mean? Well, I'll just zoom in. Let's take 2 points. Let's take that one because it's easy to read, 0, 4. And let's take this one, which is 2, 0. Okay, so we have 0, 4, and we have a 2, 0. Okay, just making sure I write them down in the right order. I could, of course, use the slope formula, y2 minus y1 over x2 minus x1. So I'm getting minus 4 over 2, or a slope of minus 2. Okay, so that's how I would do it with the slope formula. Could I have done it with rise over run? Well, yes. If you compare here, there's a 1, 2, 3, 4. There's a rise of 4. Over a run of 2. Okay, how did I know how far to come over? Well, you have to pick 2 visual points on the line, and the easiest ones to pick are like where they cross fully on a set of boxes. Do you see, that's a perfect point to take. I could take that one. I could take that one, but not these ones in the middle where they kind of half cross boxes. Okay, could I have taken this one? Yes, my rise over my run would be for that one down 2, so it's minus 2, and my run over 1. So it's pick a point, how far do you come down, how far do you go over, of course, and you still get minus 2 for that. Okay, so therefore that line then is y is equal to minus 2x plus 4. We go back and we see, what line are you? Minus 2x plus 4. Okay, even if you hadn't got the slope in this one, can you see it's the only line with the y-intercept of 4, so you would have got it just from the y-intercept information alone for this particular question. So line 5 is my answer. Right. The table shows some values of x and y for the equation of one of the lines. Which equation does it satisfy? Okay, well, why do we come up with an equation of the lines in the first place? I'm just going to clear this off, okay, and I'm just going to copy it so that we don't have to keep flicking over and back. Okay. Why do we come up with equations of lines in the first place? Well, the equation of a line is a formula that links points on the line together. Okay, so, and you'll see this in action in this question. For each of these points x, y, they satisfy one of the lines. So let's try line 1. Okay, so we have 3x, sorry, we have y equals 3x minus 6. Okay, sub in your x, sub in your y. So we have 12 being equal to 3 times 7 minus 6. If this equation is on that line, then the left-hand side will be equal to the right. Okay, so for our y, we're getting 12. For the right-hand side of that equals to sign, we're getting 3 by 7 is 21 minus 6 is 15. Okay, I don't even have to go any further because I know that those points don't satisfy line 1. So I don't have to sub in 2 and 3 because it tells me that all of these values satisfy one of the lines. Okay, so let's try line 2. I'll come over here and do it. Line 2. Okay, so line 2 is y is equal to 3x plus 12. Let's sub in that first one, that first point here again, 7 and 12. 12 is equal to 3 times 7 plus 12. Well, this is all positive, 21, 31, 33. 12 is not equal to 33. It's not line 2. Let's try line 3. Y is equal to 5x plus 20. And let's try 7 and 12 again. 12 is equal to 5 times 7 plus 20. That's not going to work. And you can see any time that I've got a plus on this side, can you see, because all my numbers are positive, it's not going to work for that line. Okay, so I definitely need one of the negatives, one of the minuses to make it work. Okay, let's switch to red just to try line 4. Y is equal to x minus 7. So let's sub in 7 and 12 again. 12 is equal to 7 minus 7. It's not that line. Let's try line 5. Should have started at the bottom up, shouldn't I? Minus 2x plus 4. Let's sub in 7 and 12 again. 12 is equal to minus 2 times 7 plus 4. 12 is equal to minus 14 plus 4. 12 is equal to 10. Well, it's not equal to 10. It's not that. Line 6. Y is equal to 4x minus 16. So 12 is equal to 4 sevens minus 16. 4 by 7 minus 16. 12 is equal to 12. Okay, so that point works for line 6. Okay, now let's check the second point, which is 920, because it should work for them all. Y is equal to 4x minus 16. 20 is equal to 4 times 9 minus 16. 4 nines are 36 minus 16. That's good. And then let's try the last one, which is the coordinates 10 and 24. 4 times 10 minus 16, and that's equal to 24. Okay, so line 6. Okay, definitely should have started at the bottom for that question. Okay, and I hope that makes sense. There is one value of x which will give the same value of y for line 4 as it will for line 6. Find, using algebra, this value of x and the corresponding value of y. Okay. I'm just going to rub out the wrong answers. Okay, I'm going to leave the orange ones there so you can see what I was doing. There is one value of x which will give you the same value for line 4 and 6. So y is equal to x minus 7 is the equation for line 4. The equation for line 6 is y is equal to 4x minus 16. Okay, there's one value of x which will give you the same value of y. Okay, so if we have two equations and we need to find the common value of x, well then this is what we call simultaneous equations. Okay, so in simultaneous equations, which will be well covered in algebra videos, we either cancel the x's and then we solve for y, or we cancel the y's and we solve for x's. And it doesn't matter whether you cancel the x's or the y's, you cancel whichever one of them looks the easiest. And when I say cancel, I mean cancel to 0. Okay, so when I compare this, I see a 1x here and a 4x. Okay, well, I'd have to multiply that top one by 4 to bring this up to 4x. And then I'd have to change the signs to cancel them. When I look at my y's, I see a 1y and a 1y. Okay, they're already the same number. So I just need one of them to be plus and one to be minus so that they cancel to 0. Okay, so how do I do that? Well, you change the sign all the way across. Okay, and that's perfectly acceptable to do as long as when you change the sign for the y, you also change the sign for the x and the numbers. Okay, so y minus y cancels, so I get nothing on that side. I have x minus 4x, so I'm going to get minus 3x. And then I have minus 7 plus 16 is 9. Okay, so to solve, I need letters on one side, numbers on the other. So I'm going to bring that 3x over here, and it's already minus 3x. So when anything moves over that equals to sign, it changes sign so that you get 3x being equal to 9. Okay, the minus 3x became plus 3x, divide both sides by 3, and you get x being equal to 3. Okay, so just to explain that, does it work? Well, y is equal to x minus 7. I'll come back to verifying the answers in a minute, okay? So that's my x. How do I find my y? Well, I take either equation, 4 or 6, because remember they told you it has the same value of x, and I solve it for y. Okay, so I've just written down equation 4 there because when I looked at them, that one looked the easiest. I can pick either one. That one has smaller numbers, so I think it looks the easiest. Instead of x now, the letter x, I'm going to put in the value of 3 because I know it's 3. And 3 minus 7 is minus 4, okay? So the value of x and the value of y that these have in common, or it's actually also, if I plotted the two lines, it's also the point of intersection of those two lines. That is 3, minus 4. Okay. The next part, part G, says verify your answers to F above. This is what I was going to do when I was up here until I look down and I see actually you're asked this. So to verify answers to simultaneous equations, you have to show that the values you found, which were x equal to 3 and y is equal to minus 4, satisfies both equations. Just like when we were doing this question here, we were showing that this sequence of points satisfied line 6. Okay, while it did not satisfy any of the other ones, in other words, the left wasn't equal to the right. So take down each equation You have to do it to both. You can't just choose one. Because the whole point of simultaneous equations is that the x and the y value that you find satisfies both at the same time. So there's line 4 on the left, line 6 on the right, and now let me sub in my values. So instead of the letter y, I'm going to put in the value that I found. So -4 equals, instead of x, I'm going to put in that 3 value that I found. Okay, so I'm getting -4, 3 minus 7 is indeed equal to -4. So the left-hand side equals the right, so that's good, okay? And that little correct there that I'm doing is not like a teacher correcting, it's maths language for verified. Okay, let's try it over this side. So again, put in the y that I found equals 4 times that 3 that I found minus 16. So -4 is equal to 4 3s are 12 minus 16. 12 minus 16 is indeed equal to -4.